Alrighty guys, so in today's lecture we're going to be continuing with our study of functional groups. So last time we met we talked about 7 different types of functional groups, and today we're just going to be adding a few more to our repertoire, and basically same thing as last time. You're just going to have to identify which functional groups are in the molecules that I give you for today's assignment. So let's get into it right away. So the first type of functional group, or I guess the 8th that we're learning about, the first one today though, are called carboxylic acids. Now carboxylic acids look a little bit complicated, but they're actually pretty simple. If you notice, it's going to be something like this. So remember we talked about last time, the R just represents a carbon chain. Okay, so basically in a carboxylic acid, what we have is a carbon in the middle with a double bond to an oxygen, and right next to it it's connected to an OH. So basically a carboxylic acid is going to be a carbon, and it has a double bond, so it has a double bond with O, and it also has a single bond with OH. Okay, so it has to have both of these things. It has to have a double bond with O, and it has to have a single bond with OH. Okay, so in this structure, we're going to identify what are the carboxylic acids. So easy way to think of this is to look at the carbon. So we have a carbon here, carbon here, carbon here, and carbon here. And all we need to do is figure out, does it have a double bond with O and a single bond with OH? That's what makes it a carboxylic acid. So if we look at the first carbon right here, it has a single bond with OH, and it has a double bond with O. So it checks both these boxes. So this part right here on the right, or the left, this is going to be a carboxylic acid. I'll abbreviate it Ca. If you look at this carbon though, it has a single bond with OH, but it does not have a double bond with O, right? Because this carbon is connected to OH, and then on the left and the right, it's going to have carbon. There's no double bond with OH. So this right here is actually not going to be a carboxylic acid. This is what we learned about last time. This is going to be an alcohol. If you look at the next carbon right here, this is also going to be an alcohol, because it has a single bond with an OH, but it does not have a double bond with O. But this one on the far right, this one is going to be a carboxylic acid because it has a double bond with an O, and it has a single bond with an OH. Okay, so that's going to be a carboxylic acid. You have to have the double bond with the O, and you have to have the single bond with the OH, and as long as this side is connected to some type of carbon chain, whatever it looks like, it's going to be a carboxylic acid. Okay? Alright, so that's the first one we're going to go over today. The next one is kind of similar to a carboxylic acid. It's called an aldehyde. Okay, so an aldehyde is very similar because it's going to be a carbon that has a double bond with an O. So for an aldehyde, the definition would be a carbon with a double bond to an O. This is the same as last time, double bond with an oxygen, but it also has a single bond with a hydrogen. Okay, and it's also connected to a carbon chain. So an aldehyde is basically the same thing as a carboxylic acid. The only difference is the single bond. The single bond in a carboxylic acid is OH, but in an aldehyde, it's H. So a lot of times, some people won't even draw that H. So you'll have an aldehyde, an aldehyde that looks like, you'll have the aldehydes drawn like this, right? You'll have the carbon chain, but remember, we ignore hydrogens that are single bonded to carbon, so people will draw it just like this, and this part right here will be an aldehyde. Okay, but some people do choose to draw the H and then continue the carbon chain. It really depends on who drew it, but either way, this is going to be the exact same thing. These are both aldehydes. Just remember, it has to be a double bond with an O and a single bond with an H. Alright, the next one is also very similar. It's called ketones, and you guys might have heard this word before if, I don't know, your mom or maybe yourself have gone on something called the keto diet. During the keto diet, your body makes a lot of molecules with ketones in it, and it kind of makes your breath smell. So if you know anyone with a keto diet, don't talk too close to them. I know because of Corona right now, we shouldn't be anyway, but it's also because their breath smells bad because they're making a lot of ketones. Now, the ketones are very simple. It's basically a carbon double bonded to an O in the middle of a carbon chain, right? Because the R's are carbon chains. So a ketone might look something like this. You have a carbon double bonded with an O in the middle of a carbon chain, or you might have a carbon double bonded with an O in the middle of a carbon ring. This would also be a ketone. So this would be a ketone, and this would be a ketone. All right, the next one, an amide, is also very similar. Actually, let me write the definition for a ketone. It's basically a carbon with a double bond with an oxygen in the middle of a carbon chain. Okay, sorry about that. So the definition of a ketone is a carbon with a double bond with an oxygen in the middle of a carbon chain. The next one is called an amide, and you guys kind of see a pattern of the ones we're learning today. An amide is a carbon with a double bond to an oxygen, right? This part right here, the double bond with the oxygen. But it also has a single bond to a nitrogen. Okay, so an amide is a carbon that has a double bond to an oxygen, and it has a single bond to a nitrogen. So this looks very similar right here to an amine, right? We learned about these last time. Amines are nitrogens that are connected to carbons. But if one of the carbons that the amine is connected to happens to have a double bond with an oxygen, it's not an amine anymore. It's called an amide. So an example of an amide might look something like this. You have a carbon double bonded to an oxygen, and then there's a nitrogen. The nitrogen might just be connected to hydrogens. It might just end right there. Or sometimes the nitrogen will have one hydrogen and connect to another carbon chain. Or sometimes you'll have a nitrogen that has connections to two carbon chains. So it doesn't really matter. Just remember that if you see a nitrogen that's connected to a carbon that's connected to a double bond with an oxygen, that's going to be an amide. All right, and the last one that we'll be talking about today is something called an alkyl halide. Now, an alkyl halide is a carbon which has a single bond to something called a halogen. If we take a look at the periodic table, the halogens are the ones in this column right here. These are the halogens. Okay, so F, fluorine, chlorine, bromine, iodine, and usually it's these four usually, and those are going to be the halogens. So if you ever have a carbon connected to fluorine, so if you have carbon connected to fluorine, if you have a carbon chain connected with chlorine, if you have a carbon chain connected with bromine, or a carbon chain connected with iodine, you are going to have an alkyl halide. So an alkyl halide, you might see it in something like this. You might have like a carbon ring with a carbon chain, and they're going to be at the end of it. Okay, so that would be bromine, and this is a halogen. So that's going to be an example of an alkyl halide. Alrighty guys, so those are the 12 functional groups that we're going to be learning about in this class. For your assignment today, what you're going to do is you're going to just be looking for these functional groups in different molecules. So I'm on the Zoom call. If you guys need any help or have any questions, good luck on the assignment, and we'll see you guys next time.